Okay, so let's look at this f of x equation and see if we can't identify the initial value, the factor, the b value, which is your growth or decay factor. Tell the asymptote equation, the y-intercept. We're going to sketch the graph so that we can identify the domain and range for practice. All right, the b value is going to be pretty easy to see because it is going to be connected to your exponent of x. So in this case, our b value is 1/3. And sometimes it's nice because your b value is going to be really easy to identify because it's inside of parentheses. Now, if you want to tell if it's growth or decay, you really only need to focus on growth. If your b value is greater than 1, it is going to always be growth. And if it's not greater than 1, then you know it can't be growth, it has to be decay. So if I look at 1/3, I obviously know 1/3 is not greater than 1, so it is decay. And again, we're going to look at decay factors and exponential graphs that decay in a later lesson. All right, so now I want to find my a value. Well, remember, a is being multiplied by b. So I have an invisible number here, and now I have to decide, is that invisible number a 1 or a 0? And I've got to think, if I put a 1 or a 0 here and it makes all of this disappear and turn to 0, then it can't be 0, which means that my a value has to be a 1. And if it's a 1, then it is also telling you your y-intercept. So I know that this graph is going to cross the y-axis at the point 0, 1. So I'm going to go ahead and plot in that ordered pair here. And then I've got a head start when I start to graph my complete exponential function. Before I can write my asymptote or tell my domain and range, I am going to have to graph my exponential equation. So I am going to go to my y equals screen, and I'm going to go to y equals, and I'm going to type in this equation. And if I type in the 1, which I certainly can do, I need to make sure that my b value, my growth, my decay factor in this case, is inside the parentheses so it doesn't look like a number. I want to make sure that my a and my b are being multiplied. And I'm going to go to my table so that I can get good ordered pairs. And you can see 0, 1, that's a y-intercept. I already have that graph. And I'm looking for whole number ordered pairs. And it looks like as I go down in my table, I'm getting fractions where the denominator is getting bigger and bigger. So that tells me that my graph and my y values are getting closer to 0. So I'm going to go up. And I can certainly graph the point -1, 3. So I'm going to graph -1, 3. And then if I go up again, I can graph -2, 9. So I'm going to go up to -2, 9. And then my next ordered pair is going to be -3, 27, which is going to be off my coordinate plane. So these are the only 3 points that I can graph. So I'm going to go ahead and connect them because they did not tell me that I needed to skip over or leave out any x values, so I'm going to connect that graph to show it is a continuous domain. And then if you notice, as I go down in my table where my x values get more positive, my number gets smaller and smaller, which tells me that my y values are getting closer to 0. So my graph is going to flatten out towards that x-axis. And I'm going to go ahead and draw that in like this. Make that a little thicker. Now I want to be careful. I want to make sure that my graph does not touch the x-axis because of this special boundary line, the asymptote. And I'm actually going to highlight the x-axis because that's where my exponential function is flattening out. And I'm going to write on here asymptote. Okay, and remember the asymptote is a horizontal line. It's a HOI. So I want to remember what those pieces of information are telling me. And remember, H is telling you that your graph line is going to be horizontal. Okay, the O is telling you that your slope is equal to 0. So M equals 0 because all flat lines have a 0 slope. And then the Y is to help you remember your equation, that the equation for a horizontal line is not x equals, it is y equals. So I know if I'm going to write this horizontal asymptote equation, it's got to be y equals. And now I want to ask myself, if I'm standing on this x-axis, anywhere on the x-axis, what are our y values always for an ordered pair that is located on the x-axis? It is 0. So I'm going to put my equation is y equals 0 because my y value is always going to be 0 on that asymptote, which happens to be the x-axis. And so now I have a sketch of my graph, and now I can write my domain and my range. So remember, a domain is how far left, how far right. And because I have an arrow at this end, I'm not only going up, I am also going out to the left forever. And because I am flattening out to the right, I'm going to the right forever, which makes my domain, if I'm going out in both directions and using every x value possible, my domain is all real numbers. Okay, so now I want to find my range. So again, I'm going to ask myself the 2 questions for range, and those questions would be, how far down? Well, I already know how far down my graph goes. It goes as far down as the x-axis. It doesn't go any lower than that. So that would be y is greater than 0. And remember, at the asymptote, it never touches. It's going to never touch or cross, so I'm going to leave it as greater than. I'm not going to have a bar and make it greater than or equal to. And so now I'm going to look at how far up my graph goes on the y-axis, and I run into an arrow which tells me that it keeps going up, it never stops, so I can't draw a boundary line. So my range for this exponential function is y is greater than 0.